Okay, so I just pulled a couple of problems from your book. Each graph in problem 11 through 18, we'll just probably look at these, is a polynomial. What's the minimum degree? Part A. And then is the leading coefficient negative or positive? So I'm going to look here for part A. The degree is I'm looking at how many x-intercepts I have. So I'm going to count 1, 2, and I think that it makes 3. So 3 x-intercepts means it's probably at least degree 3. It could be degree 5 because you can have like a lower number of x-intercepts than the degree, but I can't be degree 2. Okay? Now, the interesting thing here is that I also have this end behavior. Look at this. Both of these are going down, which doesn't happen in an odd degree function. So actually, I'm going to change that and say, because of the end behavior, I think I need a degree 4 polynomial. Okay? Then if this is degree 4, then I have a negative coefficient, leading coefficient. Because positive for even degrees looks like up and up, and negative looks like down and down, and these I have down and down. Does that make sense? Okay. Now, this one here is kind of interesting, part 12. So I think this is part A. A, minimum degree should be 4. B, it should be negative. A has 0 x-intercepts. I'm going to make some notes over here. Let me just erase these two. Zero x-intercepts. But the leading term, or leading the end behavior is what I want to say, says that this has to be even. Right? They're both going in the same direction. So it probably has at least degree 2. That's the lowest even function. And it has to be, again, be negative because they're down and down. Okay? Okay. And then I pulled this other one, or a couple. It says, write an equation for the lowest degree polynomial function with the graph and intercepts shown in the figure. So I just want to kind of talk about this. So I want to maybe think about working backwards. So I'll remind you that we were looking at this function f of x is equal to x to the 4th plus 5x cubed. We factored this, and we got x is equal to 0 and x is equal to negative 5. So it turns out that these two forms, the zeros and then this factored form, are just very closely related. Do you guys see that? So it turns out if x is a 0, I want to write this down, or if x is an x-intercept, maybe I'll write, if I have a number a, is an x-intercept, then in factored form, f of x has the factor x minus a. Okay, so like here, if I knew from this previous example, and I want to show you what I mean, if I know that 0 is an x-intercept, then x minus 0 is a factor, and x minus negative 5 is my other one, is also a factor. X minus 0 simplifies to be just x, and this will be x plus 5. Now this isn't exactly the factored form, because 0 is a factor that happens more than once, and I didn't know that without knowing the degree. But I get kind of pretty close to some sort of factored form that's reasonably close to my original function. Okay? There are, like this example will show you, if you just know the x-intercepts, there are multiple functions that fit this, but you can kind of get close, okay? So these two questions ask you to write an equation for the lowest degree polynomial function with the graph and intercepts shown in the figure. So this really asks you to bring together quite a few things, like this end behavior, the degree, and now this piece about what these intercepts mean, okay? So I count here, I have two x-intercepts. It looks like they happen at x-intercepts at what? -2 and 1. Okay. I think that the degree is there. That has 2. There's 2 x-intercepts. So I think it has to be at least degree 2. Okay. It's also pointing down, both down, so I think it has to be negative at the front. Okay. So I'm going to try and build it. I want f of x. I want negative to be at the very front. And then I want x minus -2 in there, and x minus 1. So I'll get negative x plus 2, x minus 1, and I'll FOIL this out, so I'll get negative, I'm going to keep this negative at the front, x squared plus x minus 2. So I'm going to go with negative x squared plus x minus 2 as one possibility for this function. Okay? So again, in 55, like if you want to try one of these, just pause the video and then you can try it, and then you can unpause and come back. Here I have 1, 2, 3 intercepts. So I think the degree has to be at least 3, possibly. The intercepts happen at -2, 0, and +2. My end behavior looks like, for an odd function, right? They're going in different directions, and it looks negative. This is the negative behavior of a negative leading coefficient. Okay? So again, f of x, I'm going to stick a negative out front in front of all these parentheses, and I'm going to do x plus 2 times x minus 0 times x plus 2. What happened? This is a minus 2. This x plus 2 is x minus -2. That's right. Okay. So I have negative. This x in the middle is just going to be an x, and I'm going to bring it out there. And then I have x plus 2 and x minus 2, which I'll multiply together because that foils really nicely. So negative x, this is x squared minus 4. So this is negative x cubed minus 4x is a possibility for this function. Okay?